Hello, here Gerald. I want to show you a video tutorial on bow skirt. Bow skirt is a double layer dress, and this kind of clothes need a very sophisticated self-cohesion. I show you the animation I want to do with bow skirt. It is a dance which allow to show diverse complex movements. Okay, I stop and I go to the beginning. Now I will start VWD. I import Genesis 2 as collision object with the default parameters, and I import bow skirt. I close. I will reinitialize the parameters. Okay, I will keep these values. I will zoom. Okay, I keep these values. I want to apply self collision. I will apply a collision distance equal to 0.5. It is correct. This detection distance to 1. I will use a method by normals and in the two directions. Now I close. I don't want to use rigidification by neighborhood because it is difficult to manage a double layer using this kind of rigidification. It is always better to use self-collision rigidification by extinction. Okay, I keep all these parameters and I apply these settings. Okay, now I have to nail some vertices on the character. I will use the first and springs, and I will make a selection using the free edge. It is always a good method. We don't see many vertices selected, but they are selected at the bottom and the chest. I will make an extension by neighborhood. Okay, it is a good selection. I remove the bottom of the dress. Okay, this seems a good selection for the nailed collision. Okay, press the button. Okay, now we can try a first simulation and look what happens. The dress folds and the dress seems very soft, too soft. We want to that the dress keep its shape, and it is not the case in this simulation. There are some defaults. Here there is a fold with unneeded fold, which can be resolved using a scale on this part. and the bow is very soft. It is if it fall too much. Okay, we can stop the simulation and we go to the simulation history. All this part is correct. The collision is correct. The close is not correct. We want to rigidify the close, and the nail collision is correct. I go to the close, and I will use rigidification harder. I will use a value of 0.01. Back. Okay. I want to apply this modification, so I modify the line and I restart the scene. There is the capture which appears. Okay, the parameters are applied. Okay, now I want to make a scale on this part. So I select the vertices on this part and I will apply a scale value. 96% seems to be a good value in all the direction. I apply. Okay, now I want to rigidify the bow. I select the bow part. I want to select the two parts of the bow. I make a plus, memory plus. I select the second part, memory plus, and I show all the selected vertices. These vertices must be rigidified a lot. So I will apply a distance equal to 1 and a softness equal to 0.01, which is a very hard rigidification. I apply this rigidification. Okay, now we can restart the simulation and see what's happened. Restart. The top of the dress works better. We can show if there is some stress. No, not too much. It is correct. Okay, the bow seems to work correctly, but the dress is more rigid, but the self-collision don't work correctly. It don't work correctly because by security, the self-collision use for each vertex a list of neighbor vertices which can be enter in the self-collision. If these vertices which can be used in the self-collision are part on a rigidification by neighborhood, this will generate hard stress, hard instability. To avoid this problem, the selection of these neighborhood vertices are made by neighborhood. there is a solution in the program to use these vertices as this selection as the structure of the mesh as extension. I stop the simulation and I go to the simulation history because I have to restart the program. All these parameters are correct, and then I keep them. I restart the scene. All the things are applied automatically. Okay. Now I want to use the two parts of the bottom of the dress, on which I want to have the self collision. I will use on these two parts self collision by extension. I go to the forces and springs. I select the inner part. I select the outer part, and I show all the vertices. On these vertices, I will apply a self collision by extension. Okay, now I can restart the simulation. The behavior of the dress is fully different because the clothes will okay. The simulation seems correct. The self collision seems to work correctly. Okay. There is normally this default should be more visible. But when I select the vertices near the hip, some of these vertices are part of, it is visible here, of the nail to collision on the character. And this generates generally a stress. It is not really visible here. But generally, it is better to remove some vertices on the edge of the part on which we want to apply a self collision by extension. I restart the simulation history and I select the self collision by extension and I press sup to delete this part, and I regenerate the scene. All the settings are applied. Okay. I will reapply the self collision by extension by removing some vertices on the top of this part. I use the springs, force and springs. I make a selection of the inner part of the dress. I select the out part of the dress. Okay. Now I want to remove some parts on the top. These vertices are in the first memory. I can make a selection by free edge, extend this selection using an extension by neighborhood. Okay, 2 times. I want to keep the vertices at the bottom of the dress for the self-collision by extension. So I remove these vertices. Okay. And I press the memory minus on the first memory. I show the vertices on the current vertices are exactly the vertices I want to on which I want to apply the self-collision by extension. I apply this selection and I restart the simulation. It is not really visible, but now you have a transition software on the part near the hip. All seems to work correctly. The simulation will take a lot of time to be realized. When the program will be on GPU, the result will be very faster. Okay, all seems to work correctly. The bow worked well. Okay. I will stop the recording of the simulation because there is no interest to see the program runs for so long time. So I stop the recording. I restart the recording of the simulation. The simulation is almost finished. And we will see the results. The self-collision continues to work correctly. Okay, there are the last frames. Okay. There are some small defaults. We will see this in the studio when we will send the simulation to the host. Okay, I start the sending. but this will take a lot of time too. So I will just begin to do it. Then I will stop the recording once more time. Okay. The interpretation of the simulation is very long. I stop the recording. I restart the recording of the importation. It is almost finished. Okay. Now we can play the simulation. There's some defaults. These defaults can be corrected by increasing the subsample value on the number of iteration value. But it is a first test, simple test of both simulation. It is important to see that when the studio make play the animation, it don't make all the correction on Genesis and when it is played at a quick time, the body go through the clothes. Okay. I hope this tutorial will be useful to you, and thank you for listening. Bye.